Welcome everyone to the first of two public forums on carbon reduction policies for the North Carolina power sector. We intend to provide the same content in each forum so that members of the public only need to attend one of these sessions. The second forum will be held the evening of Wednesday, September 16th from 6 to 8 p.m. and we'll be sending out an invitation. Just a note, and we've just noticed this as well in writing, thanks Janelle, that this session is being recorded for the benefit of those who can't attend either of these meetings, or for those of you who don't get enough even when you do attend and want to go back and watch a particular piece of it. We'll be posting the recording on the Duke Nicholas Institute website, where you can also submit written feedback about this process. We'll provide the link to that webpage at the end of today's program. My name is Kate Konchnik, and I direct the Climate and Energy Program at the Duke University Nicholas Institute for Environmental Policy Solutions. I'll be presenting today with my colleagues Jonas Monist, who is a law professor at UNC Chapel Hill, and Jen Weiss, who's a senior policy associate at the Duke Nicholas Institute with me. Jen is going to be moderating the question and answer sections of the program and will be keeping us on track to make sure that we cover everything that we intended to share with you today over the next 2 hours. So thanks in advance to Jen, because that's probably the toughest role of the day. Last fall, after a year of public outreach and engagement, the North Carolina Department of Environmental Quality published the State Clean Energy Plan. Recommendation A1 of the plan, the top recommendation, called for a report to present specific policies for cutting carbon pollution from the electricity that we use in North Carolina. Our goal for today is to share information about the work we've been doing with stakeholders to tackle that recommendation and to hear your questions and feedback. Researchers from North Carolina universities are leading this effort. We've been asked to submit a report to the governor by December this year. A few initial points we want to make clear about our role as academics. We've been tasked with providing objective, high-quality information to decision makers that reflects input from stakeholders around the state of North Carolina. Our final report to the governor will not recommend a single policy or two policies or a particular path forward. Instead, what we've been asked to do and what we've decided with stakeholders is that we will be evaluating a portfolio of options, and we will provide some bases of measurement or comparison between those policies for the North Carolina government and the public to act on. Because we represent academic institutions and not the state, we're not conducting a formal regulatory process for this report. That could follow next year if North Carolina chooses to act on any of these policies. Nevertheless, as academics, we place heavy emphasis on educational outreach, transparency, and collaboration. The process that we described to you today strives to meet these values. So a brief overview of the day. You'll see the agenda on the right-hand side of this slide. We're going to discuss the history of the project, starting with the Clean Energy Plan, so you know sort of where it comes from and what we were charged to do. We'll talk about the timeline and the stakeholders that have been involved so far. We'll then describe the carbon policy options that the Clean Energy Plan asked us to consider, and we'll highlight some of the decisions we've made in defining those policies with stakeholders. We'll wrap up with a deep dive, or a brief dive, not a deep dive, I promise, a brief dive into the analytical process that we are conducting. So the modeling that we're doing, the outcomes we expect from that modeling, and the ways we think we'll be presenting in the final report the different policies and how to compare them. So I'll turn it over now to Jen Weiss, who's running the show today, for some ground rules. Jen.
Thank you, Kate, and good afternoon, everyone. Thank you for joining us today. As Kate mentioned, there are going to be several opportunities today for you to ask questions during this session, and we really look forward to your active participation. From a logistical standpoint, what we'd ask that you do is to use the Q&A function, which is at the bottom of your screen on the right-hand side, to ask your questions. Ask them at any time. We will be pausing throughout the presentation to look at the questions and to answer them as they come up. We'll try to do our very best to answer all of the questions that we can today, but given that we are only here together for 2 hours, we may not be able to get to all of them. But we do want to focus today on your clarifying questions related to the process and any of the content that we share. But in addition, as Kate mentioned, we want to get your feedback as well. And so at the end of the meeting, I'll be sharing with you a way for you to provide us with additional feedback following the presentation today. If you have technical difficulties, I'd ask that you please use the chat function, which is a few buttons over to the left. If you can't see the video, if you're having trouble hearing, please use that chat function and we will attempt to fix it for you. So use the Q&A for your clarifying questions. And as I said, we'll stop along the way. Thank you so much for participating today. And I'm going to turn it over to Jonas to give you a brief history of the project.
Great, thanks, Jen, and thanks to everybody for joining us. Just I guess maybe a normal pandemic caveat here. In a few minutes, I'm going to have to get a first grader on a different Zoom. So if I look like I'm distracted, that's what's happening while I'm talking. So we wanted to start this conversation by focusing on the history of the project and provide an overview of the steps that the governor's office and the Department of Environmental Quality have taken before the universities, the Nicholas Institute and CE3 at UNC Chapel Hill, stepped in and started this specific process we're going to talk to you about. So next slide, please. So the origin, you can advance one more. The origin of this entire effort really goes back to Governor Cooper's 2018 Executive Order 80, which is often referred to as EO 80, which committed the state to addressing climate change and transitioning to a clean energy economy. It set several goals for the state. The goal that led to this particular process that we're going to be spending the next couple of hours talking about is focused on reducing greenhouse gas emissions, specifically reducing North Carolina's emissions 40% below our 2005 levels and achieving that goal by 2025. EO 80 also instructed the North Carolina Department of Environmental Quality to develop a clean energy plan that's focusing on encouraging utilization of clean energy resources, including energy efficiency, solar, wind, energy storage, and other technologies. DEQ initiated a year-long engaged process focused on facilitated workshops, regional listening sessions across the state, statewide events. They collected online input and they developed a clean energy plan, which was delivered to the governor in October of 2019. The clean energy plan is a long document. It includes a long suite of recommendations to achieve the governor's goals. Some of those goals focused on the power sector specifically, some of the goals focused more broadly. This part of the project, the clean energy plan project that we're focusing on here is specifically aimed at the power sector. So here are the clean energy plan's goals, focusing on the power sector. So one specific target by 2030, reducing emissions from the electric power sector specifically by 70% by the time we reach 2030, right? So we're starting with the 2005 level, reducing that level by 70% by 2030 and achieving net carbon neutrality by 2050. I want to highlight here that the clean energy plan doesn't define carbon neutrality, right? So that could mean zero emissions, doesn't necessarily have to mean zero emissions. Carbon neutrality is just making sure that for the amount of carbon pollution that is emitted from the electric power sector by 2050, there are other measures in place to pull the equal amount of CO2 out of the atmosphere to achieve that neutrality goal. Next slide, please. Great, thank you. So our process is focused on recommendation A1 in the Clean Energy Plan, and we have the 4 recommendations here. So the Clean Energy Plan identified 4 general strategies to achieve the electric power sector emission reduction goals. 1, accelerating coal retirements. 2, the market-based carbon reduction programs. 3, clean energy policies, such as an updated REPS, that's the Renewable Energy Portfolio Standard that we already have in place here in North Carolina, or a clean energy standard. EERS here is Energy Efficiency Resource Standard. And then number 4 is a combination of these strategies. So this list informs the process that we now have underway to evaluate different strategies for achieving the goals, right? This is where the Nicholas Institute and CE3 come in. The Department of Environmental Quality requested that our 2 organizations evaluate options, right, that would be consistent with these goals, deliver a report on the potential impact for North Carolina. Our role as universities, as Kate's already mentioned, is to make sure that we are identifying the trade-offs, that we are providing credible, well-researched information that is in a transparent manner, and that we're delivering it to decision makers, identifying the choices, helping evaluate the trade-offs, not making the choices themselves. To achieve that process, if you could go to the next slide, right? Taking that list of 4 strategies to achieve the decarbonization goals for the electric power sector and turning it into policy pathways with enough specificity that we can model them required making a number of trade-offs. And we wanted to make sure that we weren't making those trade-offs ourselves just as university employees, but that we were engaging with a broad group of stakeholders here in the state who have expertise to help inform those trade-offs and also have different perspectives on the value choices that underlie some of those trade-offs. The next slide has a specific timeline. I just wanted to start here. Actually, if you could go back, please. Yeah. So we started this process in December of last year, and we wanted to both, achieve that balance of making sure that we are that we're engaging the broad group of stakeholders that need to be a part of this process, but also recognizing that making some of the trade-offs, evaluating all of the different options, taking these 4 general strategies and adding enough specificity that we can model them requires a more small group discussion than we could probably facilitate through the large stakeholder group. So we have 2 general groups that have been part of this process. One is a stakeholder group. I think at our last stakeholder meeting a couple weeks ago, we had over 80 participants in that. We try to meet with the stakeholder group at least every other month. And then we also have working groups that are representatives that are also part of this broader stakeholder group. So we have one working group focused on policy, another working group focused on the technical aspects of modeling. On this slide, we also have identified some broad categories of organizations that are participating. This is not intended to be comprehensive, but we do want to give everybody on this webinar a sense of the types of perspectives that are informing the work. So environmental injustice advocates, low-income advocates, renewable energy sector representatives, representatives from the industrial sector, state agencies, universities, and then our utilities and co-ops here in the state. Okay, next slide, please. Okay, so as I mentioned, we launched this process in December of 2019. Much of the work for really the first 6 months or so has been focused on the inputs for the modeling analysis, which Kate Konchnik will talk in more detail about the modeling analysis in a few slides. I'm not going to go into that here, but I do just want to highlight again that there are a number of choices that had to be made, right? So for early retirement of coal-fired power plants, for example, what timeline, which power plants? So we've been focusing on those types of questions, and we have come up with some scenarios, some policy pathways that we're going to talk about in a few slides, go through in more detail. The goal there with those policy pathways is not to recommend any one of them. It's also not to say that these are the 4 options that we think the governor and DEQ should choose from, or the legislature should choose from at a later date. It is identifying representative policies that we can then use to compare the impacts of one versus the other, using various metrics, including cost, including greenhouse gas emissions, but also including issues like affordability and equity. The Clean Energy Plan identifies a number of values that we want to use to evaluate these options. So the timeline, really this summer is when the modeling process began in earnest. Since that date, we have been focused on testing the model, right? Identifying areas where additional data is necessary, identifying additional questions, policy questions that the modeler need to have answered in order to do the analysis. We're now moving into the stage of this process where the modeling will be underway, and we'll be delivering a final report to the governor in December of 2020. Next slide, please. So I want to end my first part of this discussion by highlighting a few key points. Kate's already touched on really all of these, but just wanted to make sure that everybody's keeping this in mind as we move forward. So first off, this is a university-led process. It's not a process that is led by government agencies. Okay? We'll be delivering the report to the governor's office, and at that point, the governor's office, legislators, the Department of Environmental Quality, can make the choices about what to do with the information that we provide to them. But this process, including today's presentation, is designed by the Nicholas Institute and CE3. Second, our goal is to be transparent and collaborative. We want to share information. We want to provide opportunities for feedback, which we will discuss more in a few slides. This is not intended to displace any regulatory process that might take place. With that, I will pause, and I believe Jen's going to take it from here. But if you have any questions or answers about the timeline or the goals or the roles of our respective organizations, happy to discuss that at this point. Anyway, let me pass it back to Jen.
Great, thanks, Jonas. So we have some time now. I know that was a lot of information. So please type your questions in there on the process or the timeline as Jonas just discussed. I do have 2 questions already, and so I will read those off to you. The first is from Omega and Brenda Wilson from the West End Revitalization Association, and they ask, how is this Carbon Policies Collaborative addressing disparities in planning and zoning of carbon producing facilities in Black, Indigenous, and Latinx communities that result in adverse health effects from birth to death? That's the first part of the question.
Okay, yeah, that's a great question. So as I mentioned, equity is one of the values that the Clean Energy Plan, so the Department of Environmental Quality, identified as important when deciding which policy pathway to move forward. Our specific modeling analysis is not going to focus on location, and I think on the equity. So I should maybe use this as a chance to say the modeling analysis will answer some of the important questions for defining North Carolina's options for decarbonizing the electricity sector. There are other important questions that quantitative modeling will not address. And equity, who bears the impact? What is our energy transition? How does it evolve? Those are critical questions. They're not questions that we can plug in some numbers into a model and get answers necessarily out of them. Our report, that is going to go to the governor's office, our report will identify the equity considerations with each one of the policy pathways. But I think the questions or the issues I think that were embedded in that question will need to be addressed at a later time by a government actor if this report, the options in the report are picked up and turned into specific policies.
Thanks, Jonas. And the follow-up to that question, also from Omega and Brenda, is this collaborative formally supporting U.S. congressional environmental justice acts and bills?
We are not endorsing any acts or bills. Again, this process is defined by the options that were laid out in the Clean Energy Plan, right? So that was a North Carolina Department of Environmental Quality effort that was a follow-on to Governor Cooper's Executive Order 80.
Thanks, Jonas. The next question is from Gail Goldsmith. I understand that this is about reduction of carbon from the energy sector, but this is only a segment of how we will reduce greenhouse gases in the atmosphere. It's only one of the segments. Carbon sinks and reduction of other greenhouse gas emissions are key. Can you tell me how these other areas can be addressed?
Yeah, I think for that, I would refer you to the Clean Energy Plan, which is available on the NCDEQ website. Again, I think it's the Clean Energy Plan itself, I think, is over 140 pages and lays out many recommendations, which are, go far beyond just the electricity sector.
Thank you. The next question is from Joseph Kuchik. Can you provide a point of contact, name and address, for someone who may have a technical innovation that might be of value in this process? And there probably are quite a few, so.
Yeah, I guess without more specificity, it's a little bit hard to answer that question. My email is available on the UNC Chapel Hill Law School website. I'd invite you to reach out to me, but again, depending on the type of technology or the type of feedback, it may be more appropriate to go to somebody at the North Carolina Department of Environmental Quality. That's a difficult question to ask. Sorry, difficult question to answer.
Thanks, Jonas. And Joseph, if you have a specific type of technology in mind, please let us know. The next question is from John Easterling. In discussing stakeholders, have these conversations included both industry and community members? Also, is there an analysis of steps that industry in North Carolina have taken to come in line with the plan thus far?
We are not doing that analysis. Again, this part of the Clean Energy Plan process is focused on the A1 recommendations, which is focused on the electric power sector. We do have participants in the stakeholder processes and the working groups that represent industrial consumers.
Great, thank you. That is all the questions I have right now. So unless I see another one, I'm going to say let's move on to the next section, which is to discuss carbon policies, and Kate's going to take that one on.
Excellent. Thank you. All right, so we just concluded the first of three main sections of this presentation, the history and the process that we're following and the stakeholders who've been involved so far. Thank you for your questions thus far. And Jen, I think I did see one other question, so maybe we could look about offsets or sort of other reductions in other parts of the economy, which maybe we could turn back to that one when deeper in this carbon policy segment. So we're now transitioning into this second portion of our session. We're going to focus on the carbon reduction policies that we are considering. And again, as Jonas said, these are derived from that list of 4 types of policy pathways that were outlined in the Clean Energy Plan. So accelerated coal retirements, market-based policies, clean energy policies, and some combination of those. That list and our discussions about policies have been attempting to capture the 3 big ways that we can reduce carbon and other air pollution from power plants. So 1, you can shut down the power plants that emit a lot of pollution, carbon pollution and other types of air pollution. You can require or encourage the building of new clean generation like solar, wind, other non-emitting resources. Or you can put a price on pollution that reflects its cost on public health and the environment and so changes the sort of incentive structure about what power plants to build and what power plants to be calling on for our electricity day today. And so those are sort of the three big ways we can move forward on this, and those clean energy plan pathways tried to capture that. So we took that list and we broke it apart a little bit further. We came up with 5 types of single policies to study. One is that accelerated coal retirement, so retiring coal plants ahead of their scheduled retirement dates. We'll talk a little bit more about that in the next slide. We then have 2 market-based policies. One is a carbon adder, so we're thinking about that as something that's used by utilities to decide what to build and to decide what generators to call on for electricity. It's not a real price, but it's a planning mechanism to sort of change the calculus of what is least cost. The third one here, which is our second market-based mechanism, is a declining carbon cap, where you basically put the generators of power pollution, of power sector pollution, under a cap, say total tons of carbon dioxide that can be emitted every year, and then you ratchet that down over time. You give the ability to buy and sell pollution under that cap between sources, and we'll talk more about that later. And then we have 2 types of clean energy policies that we decided to explore. One is a clean energy standard, which is similar to the renewable energy portfolio standard that North Carolina already has on the books. The difference is that the REPS law lists specific types of technologies that are eligible, whereas a clean energy standard would be technology neutral and would just be about getting cleaner generation over time. And then finally, other clean energy policies, we decided to see what it would look like if we just had a requirement to build particular types of clean energy. We then are going to study about what happens when some of these policies are implemented together, and whether that's just piling on or whether you can really optimize health or cost results by combining these policies. One thing to mention again, just at the outset of this, and for you to keep sort of in the back of your mind as we talk about these policies, an interesting piece of the Clean Energy Plan is that North Carolina wants to reduce carbon pollution from the electricity that we use, not just the electricity that we generate in state. So that means a policy will likely need to track where our power is coming from and what its carbon intensity is. So we've been thinking a lot about electricity imports, and it's something for you, again, just to keep in mind as we're talking about these different policies, how this might work. Now, electricity imports means a number of different things. So it can mean the power plants that Duke Energy owns in South Carolina and uses to meet some of the electricity demand in North Carolina. It could include some of the power plants that Dominion owns in Virginia, that it brings power across the line, state line from, to meet electricity demand in the northern part of North Carolina. Or it can mean periodic purchases that the utilities make from neighboring utilities. And so this will be an interesting part of the puzzle to figure out. Next slide, let's get into these policies. All right, so coal retirements. So a coal retirement policy would require or encourage some or all of North Carolina's coal burning power plants to retire before their scheduled end of life. And in one case, we're actually looking at what would happen if we required all coal to shut down by 2030 in the state. Some coal units are being retired early for purely economic reasons. And so we're trying to sort of separate that out. Some will just, they're not economic to run anymore, and so they may be retired. We're looking at a coal retirements policy that would really focus on those that would remain in operation without a climate-focused policy. Now, coal retirements policy can do one of 2 things. It can just require utilities to retire their units by a certain date. It can also, the second sort of flavor of this is to create a financial incentive that induces a utility to retire coal early. Other states have implemented both types of policies. So for instance, Virginia's legislature earlier this year passed a bill that requires coal owned by each of the major utilities to retire by a certain date. Meanwhile, states like Montana and New Mexico have passed laws allowing utilities to issue bonds that help them write down their coal assets and sort of retire those assets sooner than they had planned. One of the interesting things here is just how fluid the electricity market is these days and how rapidly costs are changing. So for instance, there are 21 units, coal units in North Carolina today. And as recently as last year, Duke Energy was reporting that they would plan to retire about 7 of those in the next decade. In their recent planning documents that they filed with the Utility Commission less than a week ago, they signaled that they could retire as many as 14 in the next decade. And this is not because of any climate or environmental policy, but just based on economics alone. So it shows how fast this situation is changing. And what our goal is to do is to really kind of focus on those units that might continue to operate without a climate forward policy that's, specifies either you need to retire these or here's some incentive to retire them early. Next slide. Okay, the second type of policy pathway we were looking at is a carbon adder. When utilities decide what power plants to build to meet electricity demand, they have to consider cost as one of the factors when they're deciding between types of generation to build. The Utilities Commission in North Carolina requires the utility to choose the least cost generation options as a way of managing the cost of electricity. So a carbon adder, what we're envisioning here is an additional sort of shadow price, and I'll explain what that means in a second, that's built into the utility spreadsheet. So when they're looking to see, all right, what's the next least cost type of power plant to build, they have to account for the pollution, the carbon pollution that an emitting unit would emit. So when they're trying to compare a cost of building a solar plant or a wind farm or a coal unit or a gas unit, for the coal and gas units, they have to add in a sort of price that reflects the social cost that's being imposed by the pollution that would be emitted. And that can, in some instances, change the calculus of what is the least cost to build. And we're calling this a shadow price because we're not actually envisioning that this would be a price that a utility has to physically pay. So there won't be a pot of money at the end of this policy that we can then use to direct to various clean energy investments, community investments, or to meet other state budgetary needs. Instead, we're just looking at this as a planning tool for sort of changing what we think about when we think about least cost. We're modeling a number of different price pathways for this carbon adder. I think we have 8 different pathways that the stakeholders have selected. And we're modeling those to see whether those baked in costs would change how many clean energy technologies show up on the grid from now to 2050. As the cost of renewable energy goes down, we're actually expecting that a lot of it will be competitive even without this kind of adder. So we may see more solar or wind being built in any event, but we want to see if these adders at different levels, if they drive more renewables on the grid or if they allow entry of more expensive technologies, for instance, battery storage. I will pass this on to Jonas to discuss the next 2 policies.
Okay, great. Thank you, Kate. So the next market-based strategy that we're modeling is the declining carbon cap. So with this policy, you would include creating a carbon budget for how much carbon can be emitted in a year. So this is the total amount of CO2 emissions from the electric power sector in a given year. Each year, the budget gets smaller, so the amount of CO2 that can be emitted collectively from the electric power sector goes down year by year. Electricity generators that emit carbon must have an allowance, or you can think of that as a credit, must have an allowance for each ton of carbon dioxide they release in a year. Allowances can be traded amongst generators or really amongst anyone who purchases allowances. Some generators may have more than they need. Some allowances may go to organizations that don't emit CO2, depending on the policy design. So the allowances themselves can be traded. This approach allows certainty about the total amount of emissions, right? So identifying a cap on emissions and allows flexibility for complying with that cap. Allowances, again, the credits, the allowances that the emitters must have at the end of the year for every ton of CO2 that they've emitted that year may be purchased, right? You can, the state can choose to sell those at an auction, or they can be given away for free, or it can be a combination of either one. Those are policy choices. In our modeling analysis, we are evaluating a policy pathway for each one of those options. So one that would include free allocation and one that would include an auction. If allowances are auctions, right, then that creates a new revenue stream, and that can be repurposed and invested in a variety of ways, including potentially investing in communities that are impacted by the pollution. To get back to a question that was asked of me a little while ago, they can be used to fund energy efficiency programs to help reduce the impact if there are cost impacts of a policy, for example. So there are a number of different choices about how that revenue stream can be used in a state. Again, we are not trying to weigh in on the merits of one versus the other, but as part of this process, we do want to evaluate both to inform the choices. Can you advance, pull up the Reggie slide? There we go. So this is a map of the states that are participating in the Regional Greenhouse Gas Initiative. So this is a carbon market that is operating in the Mid-Atlantic and Northeastern states. The Reggie market is focused specifically on electric power. Virginia recently passed legislation called the Virginia Clean Economy Act, and this is just an example of how a state can choose to use allowance revenue if the carbon market includes auctioning allowances. So the Clean Economy Act in Virginia created the Virginia Community Flood Preparedness Fund to enhance flood prevention, protection, and coastal resilience. It creates a low-interest loan program to help inland and coastal communities that are subject to recurrent funding. The sale of allowances when Virginia joins Reggie are slated to generate revenue for those funds in addition to other policies. Just one example, but just to highlight some of the choices that come along with this particular policy path. Next slide. Okay. If you remember the list from the Clean Energy Plan, one of, I think, number 3 was a broad category of clean energy policies. Our working groups have taken that broad category for purposes of defining a policy pathway for modeling, and to compare with the other options, we've narrowed that to a clean energy standard. A clean energy standard operates in a manner that's similar to our renewable energy portfolio standard that we have here in the state. I'll say more about that in a moment, but rather than focusing on energy technologies that are defined as renewable, right, this one is focusing on energy technologies that are defined as clean. There are 2 different ways that you can implement a clean energy standard. One is focused on a list of technologies that policymakers identify as meeting the definition of clean for the state. And that's similar to the renewable energy portfolio standard that we have right now. Right? That law, that North Carolina statute, identifies which technologies qualify as renewable and includes carve-outs, so mandates for certain percentages for some technologies. Another approach to implementing a clean energy standard, rather than focusing on defining the technologies, is to focus on the emissions. And for modeling purposes, that's what we have chosen to do here. We're defining clean resources as those that do not emit carbon pollution as a byproduct of generating electricity. I am spending a little bit of time focusing on the different choices here, just to highlight that for a clean energy standard, there are many choices, in the implementation that we are not grappling with in this process. We've defined one clean energy standard as a policy pathway for modeling and analysis and comparative purposes. If North Carolina's policymakers decided to move forward with a clean energy standard, there would be numerous other choices that policymakers would need to consider and grapple with, including some of the trade-offs here, right? The difference, and I'll just close this slide with just a more specific comparison of a clean energy standard as we're modeling it and the renewable energy portfolio standard. So the renewable energy portfolio standard in North Carolina identifies a carve out for solar, a carve out for electricity that is generated from methane captured at hog farms, for example. The clean energy standard, as we're defining it, is focused on the emissions aspect of the generation, not focused on what type of technology is producing that that generation. Next slide. So as Kate mentioned, we're also looking at some additional clean energy policies, and these are two areas that we've identified through the working group process and the stakeholder engagement process that are potentially could have major impacts on the trajectory of clean energy in North Carolina, or I should even just say energy in North Carolina. One is the availability of offshore wind, and two is the trajectory and adoption of battery storage in North Carolina. So because it has become clear that these two questions are so important to the other issues that we're focusing on with this A1 process, we wanted to carve out specific scenarios that are looking at, if you had a policy to incentivize and facilitate offshore wind development, what would that do to the other choices here in North Carolina? Or if you had greater adoption of battery storage, what impact would that have for renewable energy utilization and then therefore other generation assets in the state? With that, I'm going to pause. I think we have another question and answer break, so we'll turn it back over to Jen.
Great. Thanks, Kate and Jonas, for all that great information. So I am going to pause here and give you some time to think through all of that information. We just gave you a lot of information on complex policies, so please feel free to ask some questions. I'm sure if it's on the top of your mind, it is on others' minds as well, so please feel free to write those in. In the meantime, while you're writing those questions, I'm going to go back and answer one from Robin Emmons that came in at the very last minute. And I apologize, Robin, I didn't answer this one before. Robin asks, how does this plan align with or support, if at all, Durham's Climate Action Plan and the city's Duke Energy franchise agreement? And I will just say, Robin, that while we're not directly aligning with Durham's or any other city or county's climate action plans, we are in close contact with a lot of the cities and counties in North Carolina, as well as have a few of them that attend our stakeholder group. So to the extent that we can, we're trying to share the information that we are analyzing with them, and we welcome questions and comments from everyone out there as well. Thank you for the question. All right, I'm going to give you guys a few minutes here. I don't see any other questions, but I know that there are some out there. So I'm going to give you a few minutes to think through any questions.
Jen, maybe while people are thinking, this is another good chance to remind everyone that as we've gone through those policies, those are the policy pathways that we've developed in collaboration with the working groups and the broader stakeholder group. Again, this is not trying to identify the full suite of options available for North Carolina. This is not trying to say if you're going to do a clean energy plan or a carbon adder, this is necessarily the way that you should do it. These are representative pathways to allow the modeling and allow the comparison to identify the potential impacts and trade-offs.
Yep. Thank you, Jonas. All right, I don't want to have dead air, but I do want to give you time to think through any questions. Oh, I see one. Thank you. From Hayes From. Can you speak to how you are including offshore wind and storage into the modeling? Kate, do you want to take that one, or do you want to wait until after your presentation on the technical analysis?
No, I can take a shot at it now, and then if we want to follow up, if the questioner or others have more questions, we can definitely circle back. So in the models that we're using, and I will talk about the models a little bit more in more detail later, but they're capacity planning models. So they're looking big picture at all the different electricity generators in the state and feeding into the state, and then seeing what happens to them if you layer on these policies and sort of change relative prices or require some of them to shut down or require other new sources to be built. And we have stacked into the model all the possible technologies that currently exist, including sort of what their likely pollution output would be and what their likely cost would be, both to build and to run. And so things like offshore wind and storage are just baked into the model to be called on whenever it makes sense. So as you know, there's a certain amount of electricity demand that North Carolina will have. We look at different ranges of that. If we all decide to start, you know, electrifying our cars and everything else, and there's more demand, we sort of look at those scenarios and we look at, all right, if we continue as we are now, where things have been getting more efficient and demand has cut, across all of those types of scenarios, we always are looking, the model is always looking to see, given whatever policy we are modeling, what's the next least expensive electricity to call on. And so in some scenarios, offshore wind at some point becomes the next thing to draw on, or storage, and we look at different types of storage, 2 hour, 4 hour, 6 hour. You know, at some point the model will say, okay, it's time to bring this into the mix. In addition, and this was the last slide that Jonas was just talking about, we've decided to sort of, this is not a technical term, but force into the model a certain amount of offshore wind or battery storage, knowing that those tend to be more expensive technologies now, but also knowing they could meet some of the concerns about variability of renewable generation. They can help to balance the solar on land. Storage can help even out the sort of variability of solar and wind. And so given those values to the grid, we've decided, well, what would it look like if we did similar to what other states have done, like Virginia this year, if we just said, hey, you have to go ahead and build so many gigawatts of offshore wind, what would that look like? What does that do to overall emissions? What does that do to overall cost of electricity? So we'll be looking specifically at those technologies being kind of, you know, a predetermined amount of those technologies being put on the system and see what effect it has. But we might also see those technologies just sort of creep in with the other policies just because they're the next type of resource that the model chooses to select from to meet electricity demand.
Thanks, Kate. I have a question from Jody Lassiter. How do these approaches address the key concern of environmental justice communities that harmful pollution must be reduced or eliminated at the source?
Yeah, so I can
take a first.
Sure, yeah, and then please follow up if you've got more thoughts on this. So in the sort of last piece of this, we'll talk about some of the outputs we're going to get from the model and talk about how you can use that to compare policies. Sorry, I just completely lost my train of track. So there's a way of looking at, if for any of these policies, for instance, the model will tell you total carbon pollution from all generators in North Carolina as the result of a policy. It will also tell you total air pollution that's not carbon dioxide, but is like smog and soot And so we'll have those numbers that start to get at what you're talking about. Although, as Jonah said, we won't necessarily know the specific locations. Some of the policy pathways that we're looking at can get very place-based, right? So if there is a policy that says this coal unit or this coal plant has to shut down by this year, that's clearly a place-based policy that results in that emission source going away. Others of these on their own might not necessarily address a particular hotspot or overburdened community. So you can have policy that build lots of new wind and solar. They should put some pressure on old emitting plants, but they might not. They might be paired with new plants as well. So you'd want to ask where those gas plants are being built. With a declining cap, all you would be cleaning up the power sector. And in some places, the company might decide, it's a barely economic plant. It's going to be a lot better for me to just retire this. And then you would see those reductions there. But then maybe that pollution could be emitted from another plant. So one of the things we're doing, and we'll talk about this a little bit more at the end of this presentation, and I look for input and questions at that point too, is trying to figure out how we get at this. As Jonas had said, the outputs of our models are not going to necessarily answer all the place-based questions. They start to get at it, but we can also have in the report a sort of, what are questions that decision makers should ask about any of these policies? What are considerations that decision makers should factor in to selecting one or another of these policy pathways? And some of those place-based concerns are the type of thing that could be in that final report of, hey, across all of these policies, you should ask these questions.
Thanks, Kate. I'm going to follow up with that. Jody asked another question that's very similar, so I'm going to throw that one out there too. Environmental and climate justice groups have been very concerned about cap and trade because it doesn't require polluters to stop polluting in the Black, Indigenous, and person of color communities these industries have targeted. That's just a comment. I'm sorry. So it wasn't a question, but yes. And that is something that we will be looking at when we're analyzing the equity components of this, as Jonas has talked about before.
Yeah,
I'll just,
sorry.
Be easier to do this if we were all in the same room. I'll just say, Jody, on that point, other than the coal retirement pathways, all of these policies have some compliance flexibility, which was another of the values that the Clean Energy Plan included in it. I think as Kate pointed out, I'll just maybe give some specific outputs that you'll be able to look to this report and the governor and others to help illustrate. So we're looking at 2030 and we're looking at 2050, and we are using the analysis to we're using the Clean Energy Plan's goals of the emission reduction goals to frame the options. So one output is comparing these different policy pathways, right? The lowest emissions, the fastest, the lowest emissions of other pollutants in addition to greenhouse gas emissions. Another factor is the lowest cost. In terms of the carbon market design, cap and trade design, like many of these other policies, there are design strategies that other states have implemented to, recognizing that there are, different impacts of these policies on different, communities and even different sectors in the state. And we do have the benefit here in North Carolina now of being able to look to the experiences in other states to understand the impacts and the options for addressing, additional concerns in addition to the need to reduce greenhouse gas emissions.
Yeah, and I would just add on that with some specifics. I think the states that have led on some of these cap and trade policies have, as Jonas said, been learning. And so some of the specific things that they have done to address this concern are, one, in the states where they do auction off the sort of right to pollute, which is, the first time we're putting a cost on this pollution rather than allowing it to be emitted for free. Those who do auction those allowances and raise revenues some states like California have put a sizable chunk of that, I think it's 40% of all the revenues go into frontline communities, full stop, either for clean energy investment or other community investment projects related to health. So that is one way. California, New York, and New Jersey have also started thinking or have started implementing other policies alongside the market-based policy to make sure that these outcomes are minimized, the distributional impacts that you raised a concern about. So there are laws that have been implemented alongside that track just to see what happens over time with emissions to make sure that hotspots aren't being created. There are more aggressive permitting actions that can be taken with particular plants in overburdened communities. And New Jersey has just enacted a law that I have not read yet, but I have it on my desktop and hope that we can talk about this in our process. Really speaking to cumulative impacts and looking at overburdened communities and figuring out how to address those spots of concern alongside a program that caps pollution. So thanks for the question.
Yeah, really good question. And I'm going to kind of continue that train of thought with a question from Jacob Farrell. He's asked, what are some other state policies against which your team has compared these suggestions, and how have they fared in meeting their respective policy goals? He's specifically curious about other states with carbon adders, if any.
Yeah, so one of the things we started doing in the spring, as Jonas said, we spent the first sort of 6 months of this process gathering a lot of information. A lot of that was just specific data to put in the models and to sort of test run the models and work with our working groups to make sure, does this make sense to you? Some of it was to gather information about policies from other states. So we're not done with this and we're still learning. But we definitely have collected a lot of information about what other states have done. So the carbon adder one is interesting because there are a number of states, and I'm thinking off the top of my head, Colorado and Minnesota being two, but I think there's probably half a dozen states that require some sort of cost of carbon to be built into planning decisions. And that does seem to, in some instances, have changed the calculus so that the renewable then is the more obvious safe bet for what to build. States have not so far, at least in this specific way of a carbon adder, they've not so far required utilities to consider the cost of pollution when they're figuring out on any given day which power plants to turn on and how much to meet demand. So that's more of like an environmental dispatch is basically the concept there, where they would be, as people wake up in the morning and start using more electricity and the utilities trying to figure out what to dispatch, they wouldn't be dispatching just based on the cost of the fuel or operating the plant, but they would also be considering the cost of pollution. We are going ahead and modeling that, knowing that has not happened in other states. The carbon cap that Jonas talked about and that we were just discussing in these cap and trade programs kind of does that because it forces the cost of pollution into the cost of operating a plant, and so that can change dispatch decisions. But no one's actually used this carbon adder as a tool for deciding which power plants to run on any given day. So in some cases, we are looking at what other states are doing and figuring out, did they have success? What did they learn from shortcomings? And some of the environmental justice issues we just talked about, I think is very much, we have the benefit of learning from other states who sort of in their 2.0 versions have been being more proactive about where they reinvest revenues and other sort of complementary policies to attack place-based concerns. But in other cases, we're kind of moving out ahead of the pack. And so this sort of use of a carbon adder for dispatch, we're going to model it and see what happens, but we don't have other states' experience to draw from.
Thanks, Kate. So I'm going to switch over a little bit. There were a couple questions about the different segments that are being analyzed in the A1 process. Michael Stowe asks, is this focused primarily on electrical utilities, or are other segments on the hook? For example, residential, transportation, or manufacturing sites? Jonas, I think you kind of addressed that earlier. Do you want to take that one again?
Yeah, so this is focused on emissions from electric utilities, but the analysis is going to include outputs about cost impacts. So, I guess it depends on what you mean by on the hook. The compliance obligation would be the electric generators, right? But the stakeholders that are impacted either because of cost or because of changes in their community and others, right, will be more broadly. But I think that the Clean Energy Plan, as I mentioned, has numerous recommendations. This is focused on specifically on the emission reductions from, basically, if you think smokestacks from power plants.
Great, thanks, Jonas. And on a similar vein, Melissa Malcolm-Weber asks, can you talk about how your model responds to increased penetration of electric vehicles? Can we make a material difference in our power sector by going big on electric school buses, for instance?
Kate, do you want to talk about electricity demand?
Yeah, so the way we're getting at that is to think about different types of electricity demand over time. So as Jonas said, we're modeling out what these policies would do to the North Carolina electricity system from now until 2050. We're mostly looking at 2030 and 2050 because those were the years in the Clean Energy Plan where specific targets were met. But the model's going to spit out answers for sort of directionally where are we headed from now until 2050. One of the things we're doing in the modeling is not just running a policy like a carbon adder once and assuming everything is going to be static from now until 2050. We're playing with different parameters to see what really might, what sort of things beyond our control or maybe in our control based on policies might change that would have a really big impact on how the policies behave. And one of those is demand. So we can look at sort of historic demand in North Carolina. We can account for where we think the population is going to be between now and 2050. And we can sort of say, all right, well, maybe electricity demand will stay about the same. Or we can say, all right, well, maybe it's going to stay about the same, but we're also going to be making investments in energy efficiency. And so per capita, we're all going to be using less electricity for the same productive output. So maybe we'll have one scenario where we assume demand goes down, at least per capita. Now, if our population goes up, it might still overall increase. But then we will also look at electrification scenarios and see what happens if our electricity demand goes way up, but it's because we're electrifying these other sectors. And that will tell us about how the different policies behave in these different conditions, but it'll also tell us something about electrification. So it can show us, we won't know in the model that that was because of transportation, but we'll say, hey, given certain electrification of transportation projections, we're going to quantify and predict this amount of uptick in demand. And let's see what happens. Let's see which power plants are called on to meet that incremental increased demand. Is it keeping some of the older, less efficient plants online because now suddenly they can be used? Is it forcing them out more quickly and it's having us build a lot more cleaner power? Those are all really interesting questions and things we're going to be looking for. And then just a little plug, our modeler, Martin Ross at the Nicholas Institute, who's been really leading the charge on the modeling for us in this project, wrote a paper last year really focused specifically on that and looking at what happens with electrification of transportation and where we think the additional electricity would come from, and is that good for air quality or not? So I suggest people could take a look at that paper too. It was really interesting.
Okay, thanks, Kate. I'm going to continue on the modeling vein with a question from Christina K. I don't want to say your last name, Christina, because I know I'll get it wrong. In your modeling, when you look at least cost, do you also look at generation availability? For example, solar during the day, wind at night, et cetera?
Yes, so absolutely, that is critical. And there are some limitations to the type of model that we're using. It's capacity planning, so it's sort of looking big picture at the system. It's considering where the transmission lines are and how things are connected that way. But it doesn't get really detailed like on the distribution low voltage lines that you see on your street. And so this is all sort of an approximation. We can't say specifically in really granular detail about renewables and sort of where they would be put and their variability. But the capacity planning model does account for this. And what we do is run the model to cover, I think it's 16 different time slices. And that just means different hours of the day and different seasons of the year. So for instance, we look at mornings, which tend to be times of high demand when people are getting up and, at least in the old days pre-COVID, getting ready for school and work. Everyone's using their toaster and their hair dryer and other sort of electrical appliances all at once, and you see demand. There's a big difference between the morning and the summer when the sun is shining and you can call on some solar to meet that demand, and the mornings in the winter when it's dark and you have to call on different resources. And so we try through the modeling by taking those snapshots throughout the year of different times of day and different seasons of the year to capture what realistically could be called on in that given time slice to meet electricity demand.
Thanks, Kate. We do have time for a few more questions. I have one more, which I will read, but if you have a question that you've been thinking through, please feel free to type it in. The final question I have here is from Kathy Buckley, and she's looking at the sources of carbon and making sure that all sources are being considered, specifically methane and leakage from fracked gas. So Kate or Jonas, could you talk to whether that is being included in the analysis?
I'll take that. So no, we're focusing on emissions from smokestacks, right? And this is, again, building on the clean energy plan process. DEQ is certainly aware of the emissions from infrastructure and has done analysis, which I won't attempt to characterize, but they have done analysis around the greenhouse gas impacts of natural gas pipeline infrastructure specifically.
Thanks, Jonas. Okay, one more question from Cindy Holmes. Are you considering the transmission and distribution losses in your model? Are there other improvements to the grid that are being considered as well?
Yeah, so I think this starts to get into the more technical, and I don't want to misrepresent, but my understanding from the modelers is that we do consider the losses across the line, so it's sort of efficiency from the point of generation to when it gets to your house. And that we do, and this, I was starting to get at this a little bit with the last question, the model does know where all the transmission lines are, those high voltage lines, and knows what their capacity is, and knows, for instance, where you would want to put new generation to sort of make use of existing capacity, or where you would need to actually build a new line in order to accommodate new generation. So it does that. It does not get down to the distribution level, though. And so there, that's just something that we have to make clear in our final report about what the model does and what it doesn't. And it's certainly true that you would need to then do that next step of, okay, at the distribution system, at that low voltage system of wires that you see in your neighborhood, where is their capacity to be adding distributed generation, like rooftop solar or other sorts of smaller behind the meter generation.
Great. Thank you, Kate and Jonas, and thank you for all the great questions. I don't see any more right now, but we will have time at the end to ask additional questions. Oops, there's one. Nope, no more. So let's move on. So Kate, you were already talking about modeling. Let's continue down the technical analysis pathway.
All right. Okay. So yes, we've covered some of this, but I'll go through this again, and I'm sure we'll have some more questions, because this really has been a learning exercise for us, and it's been great to work with really experienced modelers to figure out how to use models that are out there to help inform these policy pathways. So again, as Jonas has mentioned a couple of times, we're not in the final report saying this is the policy to follow, this is the policy pathway to follow. Instead, we're sort of looking at all these different ways that you could cut emissions from the electricity sector, and then showing some analytical or doing some analyses of these policies to sort of describe what they would do, what we think the cost results, generation mix results, pollution results might be, and then thinking through sort of how they might be implemented. And so for this part, we just wanted to focus a little bit on the actual modeling that we were doing so that you sort of see what we've been working on and understand some of the outputs that we're going to have at the end of this that we'll have in the report. So next slide. So we are doing two kinds of modeling for this report. The first kind of modeling, and this is what we've been talking a lot about in some of the questions about the policies, is using a capacity planning model. So this is a model that maps sort of the North Carolina electricity system, but not as an island. So sort of recognizing that it has big transmission lines connecting it to other states and to other utilities. Looking at that and seeing sort of over time, given these certain other conditions that we talked about, like how much electricity are we using, how many people are here, what are the relative costs to run different kinds of power plants? Given all of that, sort of what might the system look like? Now, these are not crystal balls. They're not going to precisely identify the cost of electricity in 2042 under a particular policy. We're using these capacity planning models as directional. So they'll sort of generally, where are we headed? And generally, where could we be headed if we implemented one or more of these policies? Now, I'm saying these capacity planning models because we're actually using two models. We are using a capacity planning model that's been generated or developed in-house at the Duke University Nicholas Institute by Martin Ross. And we're using his model because since it's in-house, we get to get full access to it, and we get to kick the tires on a lot of different scenarios. So we're using this as sort of our screening model, where we get to try lots of different things. When we talked about the carbon adder, we talked about the fact that we're looking at 8 different types of prices. And so he gets to try 8 different types of prices under lots of different conditions, under high electricity demand, low electricity demand, different fuel prices that might happen over time, and gets to see what happens. We then are using a second capacity planning model, very similar model, and the modelers have been working together to use similar inputs so that we can expect similar results. But the second model is the IPM model that's used by a consulting firm, ICF. And the reason we decided to work with them for sort of the final modeling runs, or some of the final modeling runs that we would have in our report, is sort of to validate. And that's just because IPM is a model that has been around for some time. EPA, the US Environmental Protection Agency, uses a public version of it and has it on its website that people can use. Utilities use it for their utility planning process. Regulators in states use the model. Environmental advocacy groups use the model when they're intervening in rate cases, for instance, in states. And so it's a model that has been used in this field for a long time. It's familiar. And so we figured we'd pair these two. Again, they're very similar. We expect similar results, but on the one hand, we've got this in-house tool that we have free access to and can do all sorts of fun simulations with to kind of see, which of all these various conditions and things that could happen in the next 40 years really seems to matter, or 30 years really seems to matter, and which is sort of noise. And then we can have a subset of those really sort of vetted again with the IPM model that is more familiar to the policy world. So that's our first type of model that we're using. We then are using a second set of models to really deep dive into cost of policies. So we'll be doing electricity rate impact analysis and electricity bill impact analysis, and we'll be looking at sort of the broader economic impacts of these policies. Are they creating jobs in North Carolina, for instance? So this slide here is talking about our reference case for our capacity models. So we're going back to those two models that we're using, the capacity planning models that map basically North Carolina's electricity sector and tell us over time what's likely to be built and then used to meet our electricity demand, and what impacts that has for air pollution, for cost, and for just different kinds of generation that we might see in the mix. In order to be able to use these policies to really test, or to use these models to test the impact of policies, we need to have a control, right? We need to have a sort of business as usual. What would the world look like without these policies? And part of the reason we do this is because we don't know what's going to happen in the next 30 years, but we want to have a baseline that everyone can see so that we can transparently compare that baseline to all of our policies. And that just helps us figure out what work is the policy doing and what work is just economics doing over time. So in our final report, we'll have a reference case. And the reference case will say from 2020 to 2050 without any additional climate policies. So we'll have our existing renewable energy portfolio standard that North Carolina's had on the books for a while, but we won't have anything new, none of the things that we're studying. What will our generation mix look like? What's getting retired just purely on economics? What's getting built purely on economics? What is the level of greenhouse gases that are emitted from our power sector, from those smokestacks over time? What's the other pollution that's being emitted from smokestacks over time, particularly the pollutants that contribute to smog and soot, so public health pollutants. And we want to look and see a couple things with this. One is, just what do we think is going to happen in a world without carbon policies for us? And we may find, just given the economics of the power sector, it's been a very dynamic situation. And as I mentioned earlier with the coal retirements, where we see, even just from planning documents from Duke Energy last year to this year, additional coal units may be retired purely on economics. And so given that sort of change, can some of the work be done for us, even absent a policy? Will the market just sort of help reduce some of our emissions? It's a question to ask. We don't know the answer, but once we have that reference case, we can then compare the work that each of the other policies is actually doing to reduce emissions further, and we can also see the cost impacts of that. All right, next slide. Once we have that reference case, and again, we will be publishing that reference case in the report, so you've got that basis of comparison, we then are modeling our different policies. So the inputs, and this is what we've spent a lot of time on in 2020, is getting these inputs right. Martin Ross and then the ICF consultants that we're using have committed to using public data sets so that people could replicate this modeling if they wanted to. And they're pulling in information like, where are the existing generators in North Carolina? Where are the power plants situated on the grid? What are they? How efficient are they? How much pollution do they emit today? How much does it cost to run them today? We're then looking at different forecast demands, and this gets at the question about electrification. So we're looking at what might North Carolinians use for electricity over time, with or without a lot of electrified vehicles, for instance. We're looking at how much does fuel cost today, but also how much could fuel cost, and particularly natural gas and coal. What could they cost going forward, and how might that change the relative competitiveness of these types of power plants versus the ones that don't need fuel, like solar and wind? How much does it cost to build new power plants? And then what are existing policy requirements? So we do want to sort of mimic today's reality to sort of see what that looks like. And then this is also where we would build in our policy cases to see of these climate policies what happens. So the outputs that we can expect to get from the model and that we'll report, for each of these policy pathways, we will get the wholesale cost of electricity. So how much it costs to meet electricity demand from now to 2050 under these policies. We'll see how much carbon pollution is emitted from the smokestacks of North Carolina power plants as a result of this policy. We'll see how much other air pollution is emitted from those smokestacks, and we'll see the generation mix. So with this kind of information, we can start to answer some questions and have some basis of comparison between our policies, right? And again, this is just directional. These answers are not the precise answers. You will have exactly this much nitrogen oxides in your air in 2040, but we can use this as a basis of comparison. So for those of you whose entry point is public health, and you want to know what is the public health outcome of this, a starting point could be to look at those outputs about air pollution levels and how the different policies drive greater or lesser reductions of air pollution over time. If cost is a concern for you, you could start with that output of the capacity planning model that talks about the wholesale costs of electricity and see how that might be different between the policies. And so you can really start to answer these different questions. If you are a renewable energy producer, or you're a bank wanting to finance new generation, you're going to want to look at the answers that are about what types of generation get built based on these different policies. All right, next slide, please. So some of the outputs, what would be the cost? What mix of generation? What level of pollution? Are answerable directly by that capacity planning model. Additional cost questions can be answered by that second stage of modeling that we're talking about doing, looking at the electricity rates and electricity bills in North Carolina and looking at jobs impacts of different policies. You can take those pieces of information and start to answer some of your questions. Now, in addition, we have core values that the Clean Energy Plan articulated and that we've talked about in our stakeholder discussions and in our working groups that are harder to quantify. And so the two I just wanted to put here today as illustration are affordability and equity. People have different definitions for these concepts. People may point to different metrics. Here's how I would know if this has been achieved. I would look at this type of number, or I would ask people and want this kind of answer. And so what we're trying to do in our process is figure out how to define these fuzzier yet critically important values, to try to figure out, knowing what outputs we're getting from the models and knowing that not everything can be reductive and just be answered by those single data points. Can we use those data points that we're getting on cost and level of pollution and types of generation and jobs to then get at these concepts of affordability and equity? What do these things mean to people, and how could we operationalize them? How would we know if one policy versus another is more equitable? What are sort of the agreed upon metrics or evaluation tools that we would want to use to be able to compare them? In addition to looking for ways to compare the policies against one another, we also might just want to have in our report a discussion of affordability and a discussion of equity and suggestions of how any of the policies could be optimized to meet these goals. But again, we need some shared sense of definition and some shared sense of the metrics that we would be using to know if we are succeeding in these. So in conversations about affordability, we've had two really different definitions emerge so far. One from sort of the manufacturing sector, the business sector. It's not necessarily as much, can I pay my bill, but it is about competitiveness. What are our electricity rates in North Carolina versus a neighboring state, versus a state where I have a competitor? And what does that mean for my ability to bring my product to market? Whereas for low-income advocates and for consumer advocates in our working group and stakeholders, the questions have been about energy burden. Can someone pay their bill? How much of someone's income is going to covering electricity? When is that too much? And what are policies that could be implemented to address that? On the equity side, there's sort of three things that are starting to emerge, but again, we welcome more conversation on this to get a better sense of a sort of shared definition or set of definitions. But one is sort of access to clean energy. Often equity is seen as sort of reducing the disproportionate impact of bad things, but we've also heard that there's sort of a lack of access to good things that is equally important. So thinking about which of these policies can deliver clean energy to low-income communities and communities of color, or is there a way to optimize any of these policies to achieve that goal? impacts to frontline communities. This is sort of the how to mitigate the bad potential impacts. So thinking about some of the hotspots concerns of these policies. Will any of these policies lead to continued pollution in certain communities or exacerbation of that pollution? And what can we do to mitigate that or to eliminate that pollution? And then the third sort of concept that has evolved is a just transition one, and thinking about communities that have built up around fossil power plants. As those plants close, what happens to those communities, and is there a way to plan for that, to diversify the economy, to make sure that those communities have access to the sort of next generation of power production or to other benefits, to recognize their critical role in having delivered electricity to North Carolinians and others for years. So this is sort of a place where our modeling outputs, and Jonas had said this at the very beginning, our modeling outputs tell us a lot of really interesting information that help us compare our policies, but they only get us so far. And then there are these bigger concepts that we need to sort of wrap our heads around and that we are continuing to discuss to try to figure out, how do we define these? How do we know it when we see it? When we're looking at policies, how do we know that we're doing what we can to make them affordable or to make them equitable? And I think that ends this section, if we have any other questions.
Great, thanks, Kate. I'm going to kind of just continue down that pathway because Susanna Tuttle asked a good question more about resiliency, but I think it ties in. Do you think the legislation that declares utilities must go forward with the least cost should be changed, as we now understand better the full costs of climate change, which are rising more and more as we take into account the costs of natural disasters and health costs, as well as sea level rise, relocation costs?
Do you want me to take that one?
Yeah.
Well, so thanks, Susanna. I mean, that's certainly one approach, which is changing the utility commission's role, or changing how the utility commission and Duke Energy and other electricity providers evaluate different resources. There's another way to approach this, though, I think, without needing to change the focus on least cost, which is just recognizing that the issues that we're talking about in this process and that Executive Order 80 and the Clean Energy Plan target are additional variables that need to be included in that least cost analysis, and maybe challenging the time frame in which we think about least cost. So that's not an issue that this report that the Nicholas Institute and UNC are going to deliver to the governor's office is going to address, is this question of least cost. But the carbon adder pathway that Kate described is another way of getting at that least cost question, right? Under the carbon adder approach, as we're modeling it, the decision-making process for electricity generation would include a cost on carbon, in addition to other costs like fuel costs and operational costs. So there are various ways to get at that issue of least cost. We're not recommending whether a change is made or not, and I guess my answer here is just trying to point out that there are various ways to move forward with climate policy without making any change to the least cost framework that is informs the traditional rate making approach we have here in the state.
Great, thanks, Jonas. Okay, I have one more question that's come in. Actually, I think two. And we have another half an hour, so please feel free to continue putting your questions in the Q&A box. The next question is from Kathy Buckley. Do your electricity demand scenarios include some that have strong incentives for energy conservation? For example, tiered pricing where your cost per kilowatt hour increases as your usage increases?
So I'll try to take a stab at this, but I welcome both Jonas and Jen to weigh in, because we have tried to figure out the best way to address energy efficiency or energy conservation. And I think right now, at least from the modeling perspective, now how we talk about it in the report could be different, but from the modeling perspective, it has been all on the sort of demand side for now. So sort of thinking about how increased energy conservation or energy efficiency efforts might reduce demand per capita in North Carolina. And so there have been different demand scenarios that reflect that. We have not so far, and I don't know that we will in any great detail, we have not identified sort of specific policies like the one that you are identifying of sort of the way we set up pricing in order to incentivize energy efficiency. But this energy efficiency has come up over and over again. So I would say it's something which is good. I'm glad people are raising it. So I think it's something that we are still trying to figure out how much of that to discuss in our report. Do either of the other of you have this? Because I know we've had a number of conversations.
Yeah, I would just add, Kate, that I mean, exactly as you said, we're looking at the demand scenarios and how energy efficiency can reduce it. We aren't looking specifically at any pricing scenarios. I think that would be more rate design, and I think that would get into a whole other modeling exercise. So at this point, not looking at a tiered pricing type of situation, but certainly looking at what are the opportunities for energy efficiency in North Carolina and how do we weave those into the model.
And Kathy, this is Jonas. I'll just add on just a little bit more. I mean, this is, energy efficiency is one of the numerous strategies that could be included in that broad umbrella of clean energy policies for the sake of modeling, because, we had to make some choices in the working group and stakeholder processes, had to make some choices to help the modelers figure out what policy pathways we were modeling and which ones we weren't, and also recognizing that we couldn't model all of them that we think would be important. An energy efficiency resource standard and specific policies aimed at energy efficiency just aren't a part of this analytical process. But as I mentioned when I was describing the clean energy standard as pathway, there are many additional issues that would need to be considered if the clean energy option is the clean energy standard option, or some other clean energy policy option is the option that North Carolina ultimately decides upon.
Great, thanks, Jonas. I have one question that came through the chat, and I think it's from Miriam, and I think you're referring to the modeling, Miriam. So I hope I get this correct. She asked, would you break up the sectors, for example, transportation, the electric grid, manufacturing, and agriculture? I think that's what you mean, Miriam. If you mean something else, go ahead and put it in the Q&A.
Yeah, I'm not. So certainly from the the policies are focusing on the smokestacks of power plants. The question may be getting at.
Yeah, she clarified, Kate. It refers to measuring CO2 equivalent emissions.
Yeah, so that is a really important issue, and I think it's one that gets addressed in the sort of North Carolina emissions inventory. But we are really focused just on the power sector here. So we're only looking at emissions that are coming from the power sector. Indirectly, there are those other sectors that you mentioned that might be using electricity, and so that would, they would be indirectly affected. But we really are, for this particular part of the clean energy plan, just focused on the CO2 emissions coming from smokestacks of the power plants themselves. There had been another question, I think, in the first session that is a little bit connected to this, in just that it was talking about the role of other sectors. And I think someone had asked about sort of there are these other opportunities for sequestering carbon, for instance, in forests and working lands, and how that might be reflected in this. And while I think sort of a common theme throughout this presentation has been we are really just focused on the power sector, I would flag, right at the early on in this presentation, when Jonas was talking about the targets that were set out in the Clean Energy Plan for the power sector. The second target, that mid-century target, is for carbon neutrality, so a carbon neutral grid by 2050. And we have been having discussions about what that means. Now, again, our report will really be focused on the power sector part of this. But I could imagine the report saying carbon neutral could mean that the power sector gets 90% of the way there, and then potentially there is one might consider, or 95% of the way there, and then one might consider making up the difference to make it carbon neutral by investing in some of those other technologies or sequestration strategies. So I could see some of that being kind of briefly mentioned in the discussion of what does carbon neutral mean. But otherwise, we are really focused on just the power sector and the emissions that come from power plants.
Great. Thank you, Kate and Jonas. And I don't see any other questions. I will take a second just to wait and see if any come through. Kate or Jonas, is there anything that came up throughout this this presentation that you'd like to mention to the group? Nope. All right.
Well,
let's go.
The one thing, just because we didn't get questions on it, but I do think, as we said, the targets are for the carbon emissions associated with the electricity that we consume in North Carolina, and not just that is produced in North Carolina. But you may have noticed that when we discuss the policies, a state has to be sort of careful about regulating beyond its borders. So our policies, at least in the sort of initial way we've described them, were about power plants in North Carolina. But there will have to be some sort of consideration or explanation in the report, kind of thinking through how we will account for the carbon emissions from power that might cross state lines to meet North Carolina demand. So I don't have much more to say on that, but just did want to flag that, because there could otherwise seem like there was a little bit of a disconnect between the target and the policies we were describing.
Good point, Kate. Okay, let's go to the next slide, please. So I want to thank you on behalf of the entire team for your time today and for your very thoughtful questions. They were wonderful. The purpose of today's session was obviously to bring everybody up to speed with where we are with the carbon policy process in North Carolina's power sector, and we hope that we answered all of your questions today. However, this is not the end of the process, as both Kate and Jonas have mentioned before. This process is ongoing. The modeling will continue. The analysis of the different policies will continue. Those core values will continue to be evaluated. And so we welcome your questions and your feedback throughout the rest of the process. We do have a specific way that you can provide us feedback, and it's right here on this slide. Please note that it is case sensitive, so if you're going to type it in right now, it is live. Go there. Otherwise, it's also on our website, so please feel free to go to there, and it will be up through September 30th. And we really do value your feedback, and we want to use it to inform our final report. So please feel free to drop us a comment, drop us another question. I think that is it for us today. As I said before, if you think of other questions, if you'd like to attend the next session next week, next Wednesday, please feel free to attend another one. Please tell your friends and other community members. And on behalf of the entire team, thank you so much for attending today, for your time. I know is very precious. Enjoy the rest of your day, and please be safe.